Okay, so this first one here, what's the purpose of a buffer?
To keep the pH from going up and down.
Okay. Yeah, so it's not just a down thing, it's an up or down thing. All right, so I've got, what would you call these two things? A weak acid and its conjugate base,
Also known as salt of the weak acid.
also known as the salt of a weak acid, for sure. Okay. So if that thiol there, that benzene ring with the SH on it, is a weak acid, the H that's attached to the sulfur is the thing that's acidic. And when we look at the other one, then the sodium is the soluble part of the salt molecule. When that molecule goes into the water, the sodium comes off, right? We're okay with that? And then what would that that sulfur like to do on that molecule? It would go find an H. So that's why it acts like the base, because it's the conjugate. Okay, so we want to run through this whole thing. This has a pH of 7, this particular buffer. And we could calculate that out by going pH is equal to 6.6 plus the log of the base, which is the salt. And that's concentration is 1.26 molar. And then the acid is 0.5 molar. And so if you calculate that out, you'll get 7. Okay, but we're going to add this 50 milliliters of 1.2 molar hydrobromic acid, and we're going to want to see how the pH is going to change. So what do we need to calculate? We need to know how many HBRs are going in, how many of the weak acids there are, and how many of the salts that there actually are, not just their concentration. So 1.2 moles per liter, and there are 0.5 liters. So 0.6 moles of hydrogen ion. Why am I not including the Br? Doesn't matter, it's a spectator ion. It's not going to do anything in the solution. So then I'll do the weak acid next. So I've got 0.5 moles per liter of the weak acid, and I've got, oh, that's wrong. Sorry, this isn't half a liter. This is 0.5, right? 50 milliliters. So that's, there we go. This one's half a liter. And so this one will be 0.25 moles. And then I'm just going to write HA, which is the abbreviation for the weak acid. And then we'll do 1.26 moles per liter divided by the same, or multiplied by the same half. So 6.9? No? 6 point, what is that? That's 0.6, and then 0.63. Okay. So then I'll do an ice table. So my weak acid in conjunction with my salt. So I've got 0.25 moles of my weak acid, and I've got 0.63 moles of my salt. And I'm adding an acid to this. So tell me what's going to happen. I'm adding an acid, so the pH is going to go down. Okay. What else?
We're going to add the 0.06 moles to the acid and subtract from the conjugate base.
Yep. So we're talking about this being an acid, right? So the thing that's going to go up is the amount of acid that's in the solution. So I'm going to add 0.06 here and subtract 0.06 here. So I get 0.31 and I get 0.56, 7. Okay, add or subtract today. There we go. So then I've got pH is equal to 6.6 plus the log of 0.57 divided by 0.31. And what's that work out to be? 6.6, 0.6 plus the log of 0.57 divided by 0.31, close parentheses, equals 6 point, how many sig figs we got here? 3, 6, 2, 6.9. So with 2 sig figs, we've got a pH that's equal to 6.9. So how much of a pH change did we have? Not much. Okay, so buffer did its job. We're going to do another one of those. I want to know what the initial pH of the buffer is. I want to know what the resulting pH is. So my pH is equal to, and then I have to look up citric acid. Okay, so I've got 3 citric acid values here. Which pKa am I going to use? Just the first one. You can only have the first one used for a buffer. So 3.14. So 3.14 plus log of 0.25 divided by 0.62. So 3.14 plus log 0.25 divided by 0.62. So this particular buffer is going to buffer at 2.75. And we're going to throw in some hydrobromic acid, and we're going to see what happened to its concentration, or its new pH. So I've got 2 moles per liter, and I have 0.005 liters. And so that'll give me moles of H+, and so 1, 10, 0, 1, and it's like a 2. And then we've got 0.62 moles per liter, and we have 0.755 liters. So 0.62 times 0.755, and I get 0.4681 moles of weak acid. And I've got 0.25 moles per liter and 0.755 liters. So 0.25 times 0.755, I get 0.189 moles of my salt. So then I've got an acid, I've got a salt. The initial conditions are 0.4681 and 0.189. The change in the equilibrium. So my change is going to be, I'm adding acid, hydrobromic acid, so the acid number is going to go up. So this will go to 0.01, and this will be minus 0.01. And so I'll have 0.179 and 0.1781. And so my pH of my buffer now is going to be 3.14 plus the log of 0.179 divided by 0.4781. So 3.14 plus log 0.179 divided by 0.4781 close equals 2.71. Okay. So here was my pH before, and then there was my pH after. All right. Do you have questions about this?
So you don't add the milliliters together, right?
No.
Because you're figuring them out separately.
Because you're figuring out moles, so it really doesn't matter what the total volume is. You're right, the new volume is going to be 760 milliliters, but we calculated how many actual particles there are, so we don't care what the size of the solution is at that point.